This video is a couple sample problems for heat calculations. It uses the equation Q equals mc delta T. So we're just going to walk through how to do a couple of these, and then hopefully that will help you understand a little bit better when you get stuck. So these are just problems just like any other chemistry problem, where the first step is to read the question and identify the givens and the unknowns. So the temperature of a 95.4 gram piece of copper increases from 25.0 degrees Celsius to 48.0 degrees Celsius when the copper absorbs 849 joules of heat. What is the specific heat of the copper? So I want to identify any of the givens. So remember, those are just the things that have any kind of number and unit with them. So 95.4 grams is a given. That's a piece of information I need. And then it says the temperature increases from, so I've got increases from 25 degrees Celsius to 48 degrees Celsius. And then I've got 849 joules of heat. Those are all givens because they've got the number with the unit. Then I want the unknown. What am I trying to find? Well, it wants to know what is the specific heat of copper, which this entire problem is all about copper. So that makes it pretty easy. We don't have two substances we're talking about, just the one. The next thing I want to do is figure out what kind of problem is this. Well, this is one where what I want to do is use an equation, and all of the problems in this unit are going to use this equation. We've got Q equals mc delta T, which looks like it has a lot going on, but it's not all that bad. Remember, Q stands for heat, or the quantity of heat. M is for mass. C is for specific heat capacity or specific heat. And delta T is the change in temperature. So I'm just going to set up a little kind of list on the side and identify my givens because I've got a lot of information in the problem. So Q, or my quantity of heat, that's always measured in joules or calories. So this is in joules. So I want 849 joules. M is for mass, which is measured in grams. So that's this one up here. It's 95.4 grams. C is my specific heat capacity. So I'm looking here. I don't know. So I'm going to just put a little question mark. And delta T. Now delta means change in or change of temperature. So delta, we can write that out as the final minus the initial, or temperature final minus temperature initial, which in this case, your finals where you end up or you go to. So I'm going to 48 degrees Celsius and minus my initial, or starting, where I'm coming from. So I'm starting from 25 degrees Celsius. So I'll just pop that in my calculator or do it in your head, whichever one works for you. So 48 minus 25 equals 23 degrees Celsius. See that I kept all of my units here. That's really important. We want all of our units. The next step is to just plug this in. Each variable goes into the equation, just like you would plug in an X in math class. Now we're just plugging in different letters. So here, Q, well, Q is equal to 849 joules. So just rewrite 849 joules equals M. My M is 95.4 grams times C, which is my unknown. So I'm just going to keep it as C. That's my variable. Times delta T. Now remember, delta T is this last bit here, so it's 23 degrees Celsius. So what I can see is that my joules are all over here on the left, my grams are here, my degrees Celsius is here, and I'm just looking for this C. So that gets a little bit confusing, so you might, because we've got two C's, so you might want to substitute in this as literally X. whichever works for you. I tend to prefer X, so I'm just going to substitute that out real quick. It's just X gets mixed up with your multiplication as well. So find whatever works for you. And then we're just solving for this X. So we've got things multiplied together with X. So to undo that, we're going to divide both sides by anything X is multiplied by. So first it's multiplied by 95.4 grams. So I'll divide both sides by that. And then it's also multiplied by 23. So I will divide by 23 degrees Celsius on both sides. And then I can see that here nothing cancels out, but here all of this cancels out. So I'm left with just X, which is important. So on the left, I'm just going to put that in my calculator. I've got 849 divided by 95.4. And then this is also on the bottom, so I want to hit divided by 23. So I end up with C, or X, equals 0.387. Now it's really important to have units on anything we do. So all of the units here, it's literally all of these units. So on top is joules and on bottoms is grams degrees Celsius, which you might see as joules slash grams degrees Celsius. That all means the same thing. So this is the answer to my problem, just 0.387 joules per gram degree Celsius, which is the specific heat of copper. So now I've got a second problem for us to look at, which is a little bit different. In this one, it is asking me what is the quantity of energy in both joules and calories required to heat 2.6 grams of iron from 25 degrees Celsius to 84 degrees Celsius. It gives me the information that specific heat of iron is 0.45 joules per gram degree Celsius. So step one, I'm going to identify my unknowns, my givens and my unknowns. So I am given 2.6 grams. I'm given that it's from 25 degrees Celsius to 84 degrees Celsius. That the specific heat is 0.45 joules per gram degree Celsius. And I don't see any more numbers in there. So what am I looking for? So it wants what quantity of energy in both joules and calories. Remember that quantity is the key word here because Q stands for the quantity of heat energy. So it wants Q. So my equation, again, is Q equals mc delta T. I'm going to set up my variable list on the left, Q, mc delta T. Q is my unknown, so question mark. M is mass measured in grams, so 2.6 grams. C is my specific heat. Specific heat is C for complicated, because look at those units, it's crazy. So 0.45 joules per gram degree Celsius. And delta T is from 25 to 84. So T final minus T initial equals where I end up to minus where I came from. And that is 84 minus 25 equals 59 degrees Celsius. So then I'm just going to plug these into my equation. This one's pretty easy because it's just giving me the unknown of Q. So Q equals my M, which is 2.6 grams, times C, which is 0.45 joules per gram degrees Celsius, times delta T, which is 59 degrees Celsius. I'm going to check my units real quick. my units, my grams. See, these grams are up top and these are on the bottom, so that's going to cancel. My degrees Celsius are down here, and those are in the normal up top, so those cancel. So I know my answer is going to be in joules, which I'm okay with. So in order to find Q, I just pop in all of those numbers. They're all multiplied together. 2.6 times 0.45 times 59. So Q equals 69.03 joules. But I'm not done quite yet because it wanted both in joules and calories. So I know that joules and calories are related in that 1 calorie equals 4.184 joules. So we can do our favorite kind of chemistry. We can do unit conversions, where I'm going from this number of joules to some unknown number of calories. So I need a unit conversion. So T-tables are back! And the top left is where I'm starting from, which is 69.03 joules. And then I need my conversion factor, which is just this up here. So joules are on top, so my joules need to go on the bottom to cancel, 4.184 joules. And on top is where I'm ending up at, so 1 calorie. Then multiply across the top and divide by the bottom. So I end up with 69.03 times 1 divided by 4.184. And that gives me 16.5 calories. So this question actually asked me for 2 different answers. So I boxed both of them. I end up with 69.03 joules and 16.5 calories. Remember that the key to these problems is separating your givens and your unknowns and making sure you have this variables list. This makes your life a lot easier. Once you have your variables list, you just plug it into an equation. So keep that straight and make sure you use your units. Your units will always cancel out to give you the units you need. I hope you enjoyed our video.